All right, so good morning, good afternoon, good evening, wherever you are, and welcome to this fourth module on geo-enabling the health information system. This series is hosted by the UNICEF East Asia Pacific Regional Office and Mobile Tropical Health Network with support from TechNet 21. So as I said earlier, thank you for introducing yourselves in the chat. We'd be happy to know who's with us. And you can also tell us your name and where you're from. You can also use the chat box if you have any technical issue. I will do my best to help you, although today I'm sharing the screen, so it might be a little bit more difficult for me to have my attention everywhere. But yes, don't hesitate, I'll do my best. If you have any question during this presentation, please use the Q&A box. It's available at the bottom of your Zoom window. You should be familiar with it now. You can ask your questions at any point of the presentation, and our panelists will answer them in whenever he feels is the most appropriate moment. Finally, this session is recorded. We'll share with you the links to the video as well as the slides by email as per usual. A last point, today our presenter has some technical issues with his connection, so please bear with us. It might be that he drops at some point, but yeah, let's be patient and do our best. Thank you very much. I hope you'll enjoy this session, and I'll give the floor to Sunny. Sunny, the floor is yours.
Thanks, Steve. Once again, everyone, you're welcome to today's section on this Geo-enabling health information system workshop. We're excited and happy to have you join us on this global workshop. We are happy you're able to make it to the fourth section of this series of workshops. We have 2 remaining modules to go, and first one will be coming up next 2 weeks' time, which is 28th of August, and the last and the final one will be on the 11th of September. We indulge you to please stay put and join us, as we round up, this series of workshops. A quick reminder that the objective of this workshop is to disseminate operational guidance material that can assist countries in implementing the geo-enablement processes for health programs and the development and implementation of microplans in your countries. Please, to today's section, which is the 4th module, we have packaged an interesting series for you, for which is being split into 4 areas and will run across 2.5 hours. We indulge you to please stay put or through, but should there be need for you to drop out at some point, there won't be no problem. We're going to record this, and of course, we'll make the link available for you to also listen in at your own convenient time. In the first, we'll start with having a recap of the 3rd module, which held 2 weeks ago on the 17th of July. Then afterwards, we go in proper to, first of all, have an introduction to the geospatial data management cycle. Afterwards, we will go into the second part, which will be teaching on the implementation of the geospatial data management cycle, trying to understand and get the definition of the terminologies involved, the data specifications, and the ground references involved in the management of the geospatial data. Subsequently, we go into the 4th section, which will be how to implement the document data for us to be able to manage, for us to be able to, do the geospatial data management cycles. And of course, we finally wrap things up by understanding how to compile existing data, how to identify, and how to fill the data gaps for such management cycle. Please stay put and enjoy this section today. Thank you so much, and I'll call upon the speaker of the day, Dr. Steve, to please take the floor.
Thank you, Sonny, and welcome again to this 4th module of this global training workshop. A few slides before we move to today's agenda. Once again,
Well, I apologize. It seems that Steve dropped from the call. Please stay put. He's joining again shortly. Thank you, and sorry about this issue. but his internet connection seems unstable today.
Okay, I'm back. It's going to be fun today. Can you hear me?
Yes.
Okay. It's going to be very challenging. And all of that for having a fiber optic connection at home. So sometimes it's not enough. So hopefully it's going to be stable now. Sorry for that, guys. Next slide, please, Alexandre. So first thing to remind you is that all the training workshop material, not only the slides, right, but also the documents that I'm referring to during the different modules can be accessed freely from the Google Drive folder that you have here. I'm putting the link in the chat. You will find there already the slides for the first 4 modules that have been uploaded. And each time you see the Google Drive logo, you will know that the document in question is in the Drive. What you also have here, and I'm putting that in the chat, is the, once again, the glossary of terms that we'll be using during these modules. We have already been using that during 3 modules. And so if you have any doubt about the terminology I'm using, you can refer to this glossary. And last but not least, the link for those who have not had the chance to attend the first 3 modules, you have the link to the YouTube video for these recordings. Next. So as it was mentioned earlier also by Alexandre, this training workshop remains the occasion to ask questions, right, and share resources as well as experience. Alexandre mentioned about the Q&A. We also have a short Google Drive, Google form, sorry, for those who have kind of more elaborated questions. I would prefer or feel more comfortable to ask this question privately. I'm putting also the link in the chat. So feel free to ask questions there. We've been able to answer all of them except one question for which we are still looking for some information. So we'll try to answer as many questions as possible during the modules. If this is not possible, we'll do that in between modules. And the use of the chat was mentioned earlier by Alexandre as well, but please use that also if you have some information that you think are useful to the participants and that you would like to share with all of us. So please feel free to indicate that there. Okay, next. A recap of module 3, right? So during this module, we started by looking at the result of the geographic features identification exercise that was performed by the participants, exercise that allowed to identify different groups of geographic features, starting by those in common to all the considered programs, right? So these features were facilities, administrative units, and settlements. We then continued going through the HIS geo-enabling process by looking at defining the purpose, audience, content, and format of the final GIS-based product meant to support programs and interventions. And then the last 2 sessions looked at identifying the equipment and, more importantly, the technical expertise that is needed to generate these products before looking at how we assess the current level of geo-enablement of the health information system, a program, or an intervention. And we ended the module by going through the result of the HIS geo-enablement level assessment conducted for Asia Pacific. Next. At the end of the last module, we also looked at which countries made the cut, right, was shortlisted to potentially receive support from AppMen to develop an action plan aiming at filling the gaps identified during the assessment. So we short
Steve, can you hear us?
Yeah, I'm back. Sorry for that. So we shortlisted 6 countries, and we invited all those who actually completed the questionnaire and or attended the first modules of the regional workshop from these 6 countries to express their interest in completing the assessment and also developing such an action plan. We received a limited number of answers, as you can see here with the below table. So we received answers from 5 of the 6 countries. And based on these, in consultation with AppMen, it has been decided that at this stage, the support will only be extended to Papua New Guinea for the moment, as we need really a minimum level of involvement of both the Ministry of Health and the different programs inside the ministry and also partners to ensure the success of this exercise. So the group of people that were involved until now from Papua New Guinea will be contacted very soon to start the next step in the process and therefore work at developing this action plan. Next. So this brings us to today's module. You can actually jump to even the next one, slide 8. And the topic for today, which is a very important topic for those who have been following the workshop since the beginning, know the importance I'm putting, and everybody should be putting really on the content, right? So today we are really going to talk about the availability, the accessibility, and the quality of data, because this is really one of the major elements that will ensure the generation of GIS-based product of quality that will therefore support decision making and planning. So a bit long today, bear with us. Hopefully the internet connection is going to improve on my side. And as Sonny mentioned earlier, we're going to be looking at the geospatial data management cycle, which is used here to ensure this quality of the data.
I apologize again. Today is going a little bit choppy with Steve's connection, which is not too good. So thanks again for your patience. He's coming back shortly.
Okay, I'm back. Can you hear me?
Yes.
Okay, thanks. So we look at some specific steps, defining the terminology, data specification and ground reference, documenting the data, and also indeed compiling existing data and looking at the methods needed to fill the gaps. Next. And you can actually jump to the next one as well. So we'll start by introducing the geospatial data management cycle and how it helps assessing and improving the availability, accessibility, and quality of data. So such an assessment of the quality takes place as part of step 1 of the HIS Geo-enabling framework implementation process. You might remember this process from the previous module. This is what we are using as a reference for geo-enabling, again, the health information system, program, or an intervention. So when you are doing this kind of work, when you are embarked in this geo-enablement, At the level of the health information system, this step number one only look at the master list for a specific set of geographic features core to public health, right? Health facilities, administrative units, and settlements. Now, when you are geo-enabling a program or an intervention, during that particular step, you also need to assess the availability, accessibility, and quality of all the other data that you need to generate the GIS-based products that we defined during step B, right, which we covered during the previous module. So this is where, when you have to do this assessment, this is where the geospatial data management cycle enter the process to support this assessment, as well as the improvement of the quality of the data. Next. So the cycle itself, so the geospatial data management cycle, is documented in actually part one, the first volume of the Health GeoLab guidance document, which you will find in the Google Drive. And this cycle covers all the steps to be followed in order to define and implement proper data standards, processes, and protocols to ensure data quality. And therefore, indirectly, also the quality, of course, of the information and information products that you will be generating based on this data. It's important to emphasize here that these steps are applicable to all the different types of data that we have been talking about here. So more particularly georeference master list, as well as geospatial and statistical data. So we will be applying this process for all these data needed to then generate these products that have been defined to support the program or an intervention. Just one thing, the reason why the steps in the cycle are numbered 2 point something is that actually this cycle is part of the second step of a larger continuum, right? The data information knowledge decision-making continuum that you will find in the Health GeoLab guidance document. Next. So actually, most, if not all, the steps of the geospatial data management cycle, most not all, sorry, of the steps are being implemented at this particular stage, right? At the step one of the HIS geo-enabling process. What is being implemented at that stage are steps 2.1 to 2.8, which are the steps going from the documentation of the process until the identification of the data gaps. The steps that are aiming at filling these gaps physically, right? Once you have identified the method you're going to be used to do this, as well as hosting, maintaining, sharing, and using the final data takes place as part of the implementation of the action plan that you develop during the geo-enablement process, so during step 4 of that process. We will be talking about this during module 6, right? The regular updating of the data, and therefore indirectly of the GIS product that are generated out of this data, is itself part of the sustainability of the action plan implementation, step 5 in the process. So we'll come back as well to this during module 6 in September 11. Next. The other important thing to mention is that the geospatial data management cycle is like the technical process behind the HIS geo-enabling framework. You might remember the framework on the left here represented as a pyramid. And the geospatial data management cycle is the process behind at the back of this upper part of the pyramid, right? Which is leveraging specification standards and protocols, the technical capacity as well as technology to generate content of quality, and then use case that are supporting planning and decision making, right? So again, this is kind of like going one level deeper, more at the technical level, while the framework itself is at a bit at a higher level, even can say at the strategic level. Next. We will now go rapidly through each steps of the cycle before focusing on those that I mentioned earlier, those that are specific to data availability, accessibility, and quality. But just so that you have an idea of what is behind each of these steps. So the first step in the cycle, which does continue along all of it actually, is the documentation of the overall process. And documenting what you're doing at each step of the cycle, and it's really from the beginning, is what will really ensure that such a process can be replicated. And this not only by others, but also by yourself, if some time passes between each application, right? And especially if you are like me and have some bad memory issues, when you apply geospatial data and technologies, there's a lot of operation you're doing. There's a lot of things you are implementing on the data, different things you are trying until you finally get the result that is going to support the program or the intervention. So it's really important to note what you're doing, to also have a systematic way to name the files that you are basically generating and organize these files. We'll come back to this in a moment, so that you can really not only track back what you have done, but also repeat it in the future. You have here an example of a report, which is, according to me, a good example of a project implementation documentation. So I invite you to have a look at this and to really take the time to really write down all the things you are doing when you implement a project using geospatial data technologies. Next. The next step in the cycle consists in defining the data needs, which is actually a step that builds on the activities completed earlier in the HS Geo-enabling framework implementation process. Actually, under step B, right? Under step B, we looked at understanding and documenting the geographic context of the programs or intervention. This is something we look at during session 6, in the module 2. And then based on this, we also look at defining the purpose, audience, content, and format of the GIS-based product to be generated to support the program or intervention, which is something we look at in session 8 during module 3, right? So once you define the products, part of it is to define the content, which is directly what you're going to be using to identify the data that are needed to generate these products. We'll look at that in a bit more detail. Next. So, as just mentioned, the activities completed during step B of the overall framework implementation process provides the description of the content, right, of this GIS-based product to be generated to support the program or an intervention. Now, the content in question can be of different type, right, and depend on the application, of course, of geospatial data and technologies being used. The main type of data, this being said, very likely going to be master lists, right? And we'll spend more time on the concept of master lists today because that's an important one. Geospatial data, statistical data, of course, and you might also be using some input parameters depending on the kind of applications you are using in your work. What you have here on the right are two tables which are extracted from the Geo-enabled Microplanning Handbook. In relation to that, the one on the left, I mean the middle here, let's say, indicate the needs for a master list and or geospatial data, depending on the geographic feature that you are considering, right? And you can notice that for some type of geographic features, right, there is no need for a master list, but geospatial data. And the table on the right, it does itself provide the list of other type of data that might be needed depending on the application of geospatial data and technologies you are interested in. Next. We then have three steps that are in some way connected to each other. Because they really provide the foundation over which data quality can be assessed and then improved, and this across the 6 dimensions of data quality that you have listed here. We'll come back to this in more detail in session 13 a bit later today. Just to indicate that, of course, this is really critical for the rest of the whole cycle. Next. So before starting to compile any data, it is key to understand the importance of metadata, aka the data about the data, right? So information that is associated to the data in order to make sure that it corresponds to the use you want to do of such data. So any georeference master list, geospatial data, or statistical data that is being used, and therefore before that compiled or generated as part of the implementation of the cycle, should be properly documented. Right, and such a documentation is again what really allows to ensure that the data you have compiled is the one you need. So that's at first when you are compiling the data, but then when you are generating data and sharing it with others, this is the metadata which will allow other users to do the same, to basically identify if this is what they are looking for. So it's important to actually start to collect the information that will go in the metadata as part of the process, and also define what is the metadata profile or metadata standard that you're going to be using as a reference. So we'll come back to this in session 14 also today. Next. Once the terminology, the data specifications, the ground reference, and the metadata profiles have been defined, the compilation of the available data needed to generate the GIS-based product can start, right? So you have really defined this benchmark, basically, you will be using to assess the quality of the data, so you can compile the available and accessible data, use those benchmarks to assess the quality against these data specifications and ground reference that have been defined earlier, and you use these to identify potential gaps. It's important to note here that there might be also additional type of restrictions, right, in the use. I mean, the quality might be, of course, an important limitation, but there might also be restrictions in the use and or sharing of the data that you have compiled, and that might also lead to the need to collect new or additional data. This will be the topic of session 15 at the end of the session today. Next. Now, the gaps that have been identified at the previous step are then ideally filled, right? And these are using different approaches depending on the type of data and also the size of the gap. As mentioned earlier today, these gaps are meant to be filled and also the new data generated being validated potentially as part of the implementation of the action plan, right, to be defined at a later stage. But we will look into that also a little bit more in detail during session 15 at the end of today. Next. So now that the data has been compiled, the gaps identified, data has been then, gaps have been filled by generating or collecting or improving the existing data to reach the necessary level of quality. Then this data can be used, right, to generate the GIS-based product that have been defined at the beginning of the process. Then also that same data should ideally be hosted, maintained, proper and shared also to properly facilitate its use in other contexts. It can also be shared, of course. The whole data sharing access issue is a broader topic, but this is what you want to be trying to do as much as possible. So collecting the data once, reusing it multiple times. But for that, the higher the quality of the original data, the higher also the number of use cases that can be made out of it. Next. Last but not least, in the process, the data should regularly be updated as it will change through time. This should ideally be done as part of an updating mechanism, defined and operationalized for each type of data. It might, of course, include the collection or extraction of new data, for example, the collection of geographic coordinates, of newly opened facilities, as well as the updating of the GIS-based products that are generated out of it. This is what generates the main loop of the geospatial data management cycle. But this being said, the needs right to generate new GIS-based products might require for the process to basically restart from the beginnings, from step 2.1. Next. Okay, so now what we will do, we will really focus on three specific parts, a critical part, I will say, of the geospatial data management cycle, which are those highlighted in red here. You can refer to the free online documents that are listed on the right side for the other steps in the process. So this closes the first session for today. Let me have a look if there is any questions before we move to the next session. Yes, I see we have a few questions in the Q&A. Okay, that's okay. I'll read the question from Alefe. I have recently been relocated from the Malawi country office to South Sudan. Is there an opportunity to conduct a pre-assessment for South Sudan within the next 2 weeks? Thanks for the interest. That's of course a bit short if you look at the HIS Geo-enabling toolkit. Which is also accessible from the Google Drive and on the GeoLab website. I can put the link in the chat a little bit later. You will see that to really complete full assessment, even an assessment that will be good enough will take a little bit more than 2 weeks to do this, but that's something that can be looked into. I think we have some colleagues actually which are working in South Sudan currently. So they might want to jump in. I have the feeling that there is something going on in South Sudan along these lines. Let me just drop a message to a friend to see if there is not something going on there. I'll come back to this after. Another question from Sombagia from Sri Lanka. We have been using Survey 123 to collect the data and geo coordinates of the household, or this will difference from using tracking device. Which one provide more accuracy? Well, interesting question. We'll have part of the answer a little bit later today, because we're going to be covering these whole concept of accuracy, precision, etc., which will give you already some indication in terms of what you should be looking into in relation to not only the device, but the application you are using to decide what is the most appropriate one. So we'll cover the concept in session 13, I think, and then we'll talk a little bit about methods for filling gaps in the last session today. And then during the next module, we will be looking also at the technology aspect of this for data collection. So there are two aspects to your question. There's a question of the equipment that you are using, which might impact on the instrumental accuracy. And then there is the question of the application that might have an impact on both the accuracy and the precision that you are obtaining through the exercise. So we'll come back partly today and a bit more during the next module. Okay, thanks for this great question. Don't hesitate to ask. And also if others have answers to those questions, I don't know if everybody has access to the Q&A, or if not, you can always put your comments and answers in the chat. But let's go back to the slides and therefore the next session. If we can go to the next slide, where now we're going to be diving in more detail into the first set of steps, right, of the data management life cycle, on which I would like to focus today. So I'm referring to the steps dealing with the definition of the terminology, data specification, and ground reference. So this is quite a long and technical session, so please bear with me. As Sonny was mentioning earlier, I mean, this is meant to be as comprehensive as possible. This is recorded so that you guys can come back to the module at another time. There will certainly be a lot of new terms, new concepts, etc. Don't hesitate to come back to this and really look at the associated material to get those concepts, because they are really key to ensuring the quality of the data you will be compiling or collecting in the field, and therefore the quality of any GIS-based product you will be generating in the end. Next. So let's start with terminology. And that's really key, because agreeing on, and even more importantly, using the same terms among all involved stakeholders is basically central to any area of work, right? You need to make sure everybody have the same understanding of the different concepts you are using, so that there is no misunderstanding, there is no data collection that is basically unnecessary because it was based on a misunderstanding. So when you manage and use geospatial data and technology, there's no difference there, right? With the caveats that you need to not only look at the technical terms, which are linked to this kind of data and technologies, but also the geography of the program or the intervention that you are geo-enabling, right? Like we discussed during session 6 of the second module. It's also, of course, important to cover the terms which are sorry. Thank you. This is the one I was talking about right now. I need to be more focused on the slide number. So two main glossaries to have, right? The one that define the geography, definition of each geographic features. That's what we look at in session 6 in module 2. And also, of course, all the terminology which is linked directly to geospatial data and technologies. And you have here, there used to be a few more dictionaries, but right now it seems that this is the one that has survived on the internet and which is quite complete, which is the Esri GIS dictionary for all the terms related to geospatial data and technologies. Of course, it's also important to cover the terminology which is specific to the health information system, the program or intervention that is being geo-enabled. So two glossaries, I will say, that are kind of purely geographic in nature, geography of the program intervention, and the other one in terms of the terminology behind geospatial data and technologies, and also a more thematic glossary in relation to your own program or intervention of interest. Next. So if you do a search on Google, when it comes to data quality, you will find a lot of different ways to get it characterized, right? It's being characterized in different ways. You will find different lists of dimensions that are associated to data quality. In the GeoLab, we consider the following 6 dimensions to define data quality. Completeness, which is the absence of gaps, uniqueness, which is the absence of duplicates, timeliness, which look at ensuring that the data matches the reality, right, for a specific point in time. Accuracy, which looks at the level of correctness of the data against the reality. Validity, which ensures the conformity, specifically in terms of format, type, ranges, and then consistency, which is the absence of any contradictions between data sources. And actually, if you reach quality with the first 5, you generally obtain consistency. Now, assessing and improving data quality across these 6 dimensions requires to define measurable criteria for each of them, right? And these criteria are what you will be capturing in what we call data specifications that are applicable to geospatial and statistical data, as well as georeference master list. And you will also use remote sensing and master list as what we call ground reference in the case of geospatial data, right? I mean, the last one, I mean, this is a key concept. We'll come back to that in a moment. Now, the application of these criteria and the use of the ground reference is what ensures the minimum level of quality for the data used by an organization or a country when it comes to applications of geospatial data and technologies. Next. So let's look at the data specifications as they apply first to geospatial data. So in this case, these specifications should at least cover the following criteria when it comes to validity, accuracy, and timeliness. So there's a total of 11 criteria that needs to be defined across these 3 dimensions. We'll come back to each of them in a short while. Next. Now, still with geospatial data, when it applies to completeness and uniqueness, We need to make the distinction between the geospatial data, which is associated to a master list. So for example, an infrastructure, right? Well, you will have a master list of health facilities, and you will have geographic coordinates for these health facilities from other geospatial data, right? I mean, you will look at completeness and uniqueness in a different way. So the first type of geospatial data, for the vector format data associated to a master list, you have two types of completeness. The completeness in terms of records, right? So the data should contain all the active records that are included in the corresponding master list. That's one of the key functions of the master list, right? Is to provide the denominator and this ground reference I was mentioning earlier. And then you should have also a completeness in terms of the data elements, right? There should be a value available for all the data elements that are included in the corresponding master list again. I'll give you some examples in a short while. Now, from a uniqueness perspective, there should not be any duplicate geographic objects in the geospatial data, right? So you should not have the same health facility appearing twice on the map, basically, for example. And this is, again, where the master list is used as a ground reference to identify this uniqueness. Now, for the other types of geospatial data, which can be, for example, road networks, digital elevation model, etc., completeness is looked in terms of having all the features existing in the reality being included in the data set itself, right? So using the ground reference, again, we'll come back to this, being able to make sure that, for example, all the road segments that you see on the imagery is also including in your geospatial data. Or when you look at continuous data set like digital elevation model, for example, it means that the complete area is covered, right? There is no hole in the middle of your data set, meaning there will be an absence of altitude for certain areas. When it comes to uniqueness, of course, there's again no duplicate geographic object, means not the same road twice, or when it comes to land cover, different kind of polygons being duplicated. Sorry. Consistency, again, is itself achieved by reaching the criteria for all the other data quality dimension. So if your data set match and is aligned with all the other criteria, then you will indirectly reach consistency. Next, please. Okay, now let's dive a little bit more. That's where it becomes a bit technical. Just don't worry. I hope you don't get lost. We'll go into each of these data specifications for the validity and accuracy, quality dimensions for geospatial data, because it's important to understand certain concept there so that you can compile and generate and use data of quality. So we'll start with the validity criteria, right? The first one here being what we call geographic coordinate system. Now, as you might know, our planet is not a perfect sphere, right? But it's more like a sphere that has been flattened a bit by pressing on each pole. It's like a kind of a potato, or what we call actually the scientific term is oblate spheroid, right? So if you look here at the figure on the left, you can actually see that there is 21 kilometer difference between the distance you will measure from the center of the Earth to the pole and the distance you will measure between the same center to the equator, right? So you have kind of, you imagine like a balloon that you press a bit on both sides, and you will get the shape of our planet. So there is a need of having a kind of a model to be able to reproduce the shape of the Earth as closely as possible to the reality. And what we call a geographic coordinate system is a 3D model, basically, that is defined by different parameters to try to reproduce the shape of the Earth. So there are different parameters, the one you have here, the 4 parameters you have here on the right, which define this model, and there are several models, because again, this is not a perfect oblate spheroid, so different models that can be defined. Now, next. What is really the important thing to remember, 31, very important thing to remember is that all the data sets that you include on the map in a GIS software should present the same geographic coordinate system. It should basically be based on the same model of the potato, right? If you don't respect that, if you are combining data which are actually modeled using different representation of our planet, then you will have an impact on the location of your points and rivers and roads, etc. They're not going to be appearing in the right place on your map. You have an example here of the impact that you have by just changing the data, right? So this is only one of the 4 parameters that define the geographic coordinate system. So if you basically modify these data, which is just the position of the center of the Earth in that 3D model, you can have up to 36-meter difference on the map between one of the data, right? You have the indication correct data at the bottom in the middle, right? And then you have this bar that goes up to 40 meters, and then you have the location of exactly the same point, but in this other geographic coordinate system, so you can have up to 36-meter difference. That doesn't seem to be a lot, right? But this is actually enough for a health facility, for example, to be on the wrong side of a river, and therefore have an impact on the geographic accessibility analysis you could be conducting, right? So it's important to really be careful about that. And of course, the impact will be much bigger if you even modify some of the other parameters that are defining the geographic coordinate system. So that's the first thing to remember. Always make sure you have the same geographic coordinate system. Next one. Now, once you have decided on the 3D model producing the shape of the Earth, right? The next thing you need to look into is the way you're going to be projecting the data, because we are in a 3D representation, right? And the maps at the end, obviously, are 2D medium, right? So you have your map is on the flat surface. So what still needs to be decided is how you're going to be converting what is in the 3D world, right, the real world, into a map which is in 2 dimensions. So this is done generally by adding a map projection, what we call a map projection, to the geographic coordinate system to obtain what we call a projected coordinate system, right? And a map projection is a method you are using to convert the curved surface of the Earth to a flat surface, a flat map, right? So what you just have to imagine is like you are placing a flashlight at the center of the Earth, and then the surface of the Earth is like transparent, and you're basically projecting this image of the surface of the Earth on the flat screen, right? That's what we call basically your map projection. Now, what you can also decide is not to add any map projection, right? You say, okay, I don't want to project anything. I want just to keep my geographic coordinate system, right, with my latitude and longitude. And this is possible. And in this case, what's happening is that the data is what we call unprojected, and the GIS software is basically using the geographic coordinates as they were X and Y values on a graph, right? So it's a kind of a linear representation of the surface of the Earth, which is of course not corresponding to the reality, but that's a way to do this. This GIS software is able to do that. Just need to be remembering that, of course, what you are looking is not matching the correct surface. And of course, there will be some distortion because of the projection, right? Now, as long as your geographic coordinate system, again, the model of the potato is the same, the GIS software will be able to correctly overlay data presenting different map projection, right? Again, the model of the 3D model is the important part. All your data is based on the same 3D model, but might have been projected in different way. This is where the technology on the fly is going to be correcting everything and putting it back together, right? Next. Now, the screen on which you are projecting the surface of the Earth can be of different type, right? So you have your bulb in the middle of the globe. Now, the screen itself can be placed in different ways. And the reason for this is that you want to try to reduce the distortion linked to the projection to the minimum possible for the area of interest, right? So there are three main techniques, basically, that are used, three types of screens, if you want. The first one is called cylindrical. So it's basically a tube, a cylinder, which is placed around the planet. It can be placed in different positions. The surface of the Earth is projected on this cylinder, and this cylinder is open flat, right? So that's one way to do that. Second way is using a cone, which is a technique which is used to map mid-latitude, what we call mid-latitude regions, right? So at the level of Europe, for example, because you will have a good contact, right? The point of contact between the cone and the sphere will be quite flat at the level of the mid-latitude. And then you have the azimuthal technique, which you are typically using for the polar region, right? So three main different type of screens you can use to do the projection of the surface of the Earth. Next one. Now, and as if this was not already complicated enough, that's not an easy thing. But again, the most important thing for you to remember, same potato model. After that, you can use different type of projection depending on your needs, right? So each projection has specific properties, right? And is preserving basically particular relationship or characteristic on the map. In other words, and this applies to printed map. Again, when you are in the GIS software, you're not going to be looking at this because, again, the technologies allows to make the necessary adjustment on the fly, right? And you will obtain the right measurements, right? When you measure distance in a GIS, independent from the projection, it's going to give you the right distance. If it's calculating an area, it's going to give you the correct area. But now if you're printing the map according to a specific map projection, this printed map can only present one of the characteristics you have listed here. You cannot have all of them at the same time. It's not possible to have a map that correctly, printed map that correctly show at the same time the sizes of feature, the shape of these features, the distance, right, or the true direction. You're gonna have to make a choice for which one you want to be using, which is, for example, the reason why navigation maps, printed navigation maps, were of the true direction type, just for the purpose of making sure that boats, etc., were reaching points correctly, right? They were being able to aim in the right direction to reach destination. Next. A few examples of projections with their corresponding techniques and type also. Among these ones, what we call the Universal Transverse Mercator, aka UTM projection, is certainly the most known and used. And so, as you can see, it's a cylindrical. It's a projection that uses cylindrical technique, so the cylinder around the globe, and the type is conformal, which means if you look back at the previous slides, right, it means that it shows the correct shape of features, right? But it's not going to show the correct size. It's not going to show the correct distance once it's printed, etc. But this is the type that we use a lot. Okay, next slide. Okay, all of the, that was all these slides were just for the first validity criteria, right, related to geospatial data specification, only for the geographic coordinate system. Now, luckily, the second criteria on the validity data quality dimension is an easier one, right? I'm referring to the geographic extent of the area to be covered. What we want to ensure here is of course, that all the data sets you're going to be using as part of your project, all the layers are covering the same geographic extent, right? And this is to avoid gaps, of course, in your analysis, right? So this is a straightforward criteria, but it's important to define it, because sometimes you will be, for example, extending the area you're working on with a certain distance, with what we call a buffer, because you want to take, for example, into account the movements of people that could be happening beyond the border of the district you're looking at, right? So it's important to define what the geographic extent of this area is about. Next. Third criteria under validity is also straightforward and concern language. The only thing maybe is just you want to make sure that you include English, right? Or, definitely the most international language in your data, in addition to the national language, it's not English. And this is to allow for, of course, more extensive use of the data that you're generating. But I will say also to facilitate the use of the data in certain contexts, like emergency management context, for example, right? During an emergency, if you have a lot of external support coming in, you will want your data set to be in both national and English language, which will definitely facilitate its use, the speed at which the intervention can take place. More importantly, of course, is the use of the Unicode text encoding standard. You want to use a Unicode standard for all the data set you're dealing with. especially if your language uses what we call diacritics, right, or special symbols, because this will be the only way to keep them across, appearing correctly across all applications. The fourth validity criteria does itself deal with data format. And there are plenty of geospatial data format existing nowadays, and actually converting from one to the other is not such an issue anymore. Either, these capabilities are directly integrated in the GIS software, or you have tools allowing to pass from one format to another. You might nevertheless want to keep things simple. And in that regard, I personally continue to recommend using the shapefile format, right? For the type of applications we are doing in the health sector, this remains really the most appropriate format. That's for vector data. And then the GeoTIFF or grid format for raster data, right? When you deal then with tabular data or spreadsheet in relation to the geospatial data, I also continue to recommend the Excel format. And this for a big part because this format allows to store multiple worksheets in the same file, right? And we'll come back to this in a while when we talk about metadata and also about master list. Sorry. Next. Okay. Now it's, just one slide also because I just talked about format and I realized that, we have not talked too much about this until now. And also maybe because this is something new. Just so one slide to talk about vector versus raster format for geospatial data. So these are two different ways that can be used to represent geographic features in an electronic way in the GIS software. So in the vector format, the features, the geographic features are represented by points, by lines, which are actually connected points, right? Or by polygons, which are closed line and therefore also connected points. So this is a point-based system, right? Well, in the raster format, it's like when you take a picture, right, with your camera, the whole area is of the picture or the whole area of a raster data is the same. It's cut in small cells, right, pixels, and have values stored in each cell. And the value that is stored in each cell is allowed to represent the data. So for example, altitude can be a value corresponding to an altitude, or it can just be corresponding to a color, right, in a satellite image, for example. So these are two different formats that are being used, each of them having specific purpose and use in relation to the product you may want to be generating. Next one. So let's continue with our validity criteria. The fifth one is metadata. We talked about it earlier a bit also when we looked at one of the steps of the geospatial data management cycle. So the availability and I will say even the quality itself of the metadata in the sense of being complete is a validity criteria. So it's having a metadata, according to me, is a great is part of what constitutes the quality of a data. Sorry. We'll come back to this during session 14 because I think this is really something important that is still being underestimated nowadays. So we'll look into detail a little bit later. Okay, so that was the last validity criteria. We'll be able now to switch to those considered under the accuracy data quality dimension. Next. So we're switching to accuracy, the accuracy group of criteria, and the first criteria under this dimension is scale. I mean, you have the definition of this concept here, but basically what a scale means or does is to allow you to relate any distance on the map with the corresponding distance in the reality, right? So if you have, for example, like here, 1 to 100,000 scale map, it means that 1 centimeter you will measure on your map will be equivalent to 100,000 centimeter or 1 kilometer in the reality, right? And so this is really important to have really a clear idea of the level of zooming in a way at which you're using to look at a particular geographic information, right? And there is some related terms you might hear sometimes, which are the concept of large scale and small scale maps. What these are basically indicating is indeed the level of detail or the level of zooming that you can see on your map. So a small scale map will cover a big area, right? So if you have an A4 small scale map, you will have a big area appearing on your A4 paper, right? So it doesn't provide, that's not a map that will provide a lot of detail. It's like you're zooming really from far away. You need small size. That's where it's coming from. Small scale. You need a small size map to cover a big area, right? And then on the other side, a large scale map in the contrary will provide you much more detail. It's like you're really zooming in much more than on the small scale one. And so you can see a lot of details there. So in this case, you will need really a large size map to cover a big area of your country, for example. So this is where these concepts are coming from. Next one. The next important criteria, and this is when you are using raster format geospatial data, right? The previous criteria apply to any type of geospatial data. This one is specific to raster format, so these grids, right, with pixels and a value in each of the pixels. So in relation to that, the criteria actually here, what we call resolution, relates to the size of each of those pixels in a grid, right? And so here you have 100 meter is an example provided here. I mean, generally, I know there's a lot of different possibilities, and there are even new kind of format coming out, but generally you will want to deal with grids that are presenting square cells, and therefore each side, both sides, or all sides, I should say, of your pixel will present the same size, right? Now, what's interesting to note here is that there's a cartographic rule that exists between the scale of work that you choose, right? And also the maximum resolution that your raster data should present at that scale. And this is the kind of rules that have been completely forgotten over the past decades because of the use of GIS. I mean, we are zooming in, we are zooming out, we are combining data from different sources, different resolution, different scale. And the system is not telling you, whoa, 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 be careful, you are doing something here that is not necessarily correct. So this is one important rule which is good for you to remember, which says, for example, if we take the line that is highlighted in red, if it says that if you work at a 1 to 100,000 scale, your raster data should normally not present a resolution higher than 50 meters. So the size of your pixels should not be bigger than 50 meters if you are working at 1 to 100,000 scale, right? If it does, if your the size of your pixels is bigger, then it will not be appropriate to use this data set for that particular scale. I mean, this is another thing I really would like you to remember, because again, it's easy to combine data, different resolution, different sources, etc. But actually, you need to be very careful about that if you really want to generate products that make sense at the end of the day. Next one. Two additional very important concepts, which are unfortunately very often used wrongly or interchangeably, while they are actually very specific. I'm referring to the concept of accuracy, positional accuracy, and precision. They are definitely related to each other, but they measure two different things. And it's really, therefore, important to understand the difference between the two, right? Positional accuracy measures the positional difference between your geospatial data, I mean, your points, for example, in your geospatial data, with the exact location in the reality, right? So it's a measure of the proximity, right, to the real value if you look at statistical data, or the real location when you look at geographic coordinates, for example, right? So accuracy, measure of proximity. Precision itself is a measurement of the dispersion around that value, right? It's basically when you take a sample of geographic coordinate, you take several geographic coordinates in a particular location, it's going to be the dispersion of these points around that particular location. And that precision actually is expressed by the significant number of digits that are used to store numbers, right? So what we want to reach, of course, as much as possible is to be the closest to the reality, right? And have the smallest dispersion possible, right? So high accuracy, high precision. And here you have that, at the bottom here, you have that these two concepts illustrated under the form of graphs for an indicator, for example, where the vertical green line would be the reality, and then your distribution on the side would present what you get in terms of your measurement, right? And the accuracy is again the shift between the vertical green line and the mean of your distribution, while the precision is the dispersion around this mean value, right? And so what you want to get is the situation on the graph in the lower right, where you have the mean of your sample falling at on the real value, right? Being aligned with your vertical green line, and the dispersion being the smallest possible. So here you have high accuracy, high precision. The example on the right with the targets kind of simulate what you have with geographic coordinates or any geospatial data, right? Where the reality itself is the center of the target, the green point at the center of the target. So when you have your points, like on the first target on the left, which are very close to each other, so you have a very small dispersion, you have a high precision, but you are far away from the point you are aiming at, right, from the real location. So you have a low accuracy. So first on the left, high precision, low accuracy. The second one from the left, your points are well distributed around the center of the target, but they are dispersed. So you have a high dispersion, so low precision, but in terms of accuracy, you are very close to the reality. Second, so high precision, low precision, high accuracy. The third one, big dispersion, really not close to the reality, so low precision, low accuracy. And the last one on the right, which is what you want to be reaching, right, with all your points very close to each other. Like imagine like targets or arrows or bullets on the target, sorry. Very close to each other, low dispersion, and at the center of the target. So this is high precision, high accuracy. So just the thing is, please remember, precision and accuracy are two different things. Be careful when you use those terms to use them correctly. That's very important. Next. So let's have a look at the concept of precision, which I mentioned is related to the number of digits after the decimal point, right, in a measurement. So if we apply that at the geographic coordinate, and if we look at the equator, so at the equator, the planet has a perimeter of around 40,000 kilometers. Right? So if you want to be doing the tour of the planet at the equator, you're going to have to walk, take a boat, etc. I mean, travel during 40,000 kilometers. And that's 360 degrees, right? So 360 degrees, 4,000 kilometers, 1 degree is basically around 111,000 meters or 111 kilometers. So when you move 1 degree at the equator, along the equator, you are basically traveling 100,000 meters. So now if we look at the table, and if I look at capturing only 1 digit in a latitude, in a longitude, for example, here we have 120.9 as a longitude, basically it means that your, and this is not rounded, right? This is only taking the first digit. It means that basically this longitude is somewhere between 120.90000 and 120.99999. So it's more or less 1/10 of a degree of potential error, right? So it can be anywhere between these two values. So you make up to 1/10 of a degree of error, so 11,000 meters. So if you, at the equator, only capture the first digit, your coordinates might be wrong up to 11 kilometers, just in terms of precision, without looking at the accuracy. If now you take 2 digits, right, so 120.93, the second line, then it's a 1/100 of a degree. So up to 1 kilometer. 3 digits, 111 meters, 4 digits, 11 meters, 5 digits, 1 meter. So if you want to go down to the level of precision of the meter, you need to capture 5 digits in your geographic coordinates, right? And again, this is completely independent from the positional accuracy of your device. Coming back to the question earlier, this is very important. So it's not only a question of the device that you're using and the application you're using, but also what the application allows you to capture in terms of the number of digits after the decimal point, right? 5 digits is the minimum recommended. So you go down to the precision level of the meter. Okay, next. Now, there is also, and we are going back to these cartographic rules, and it took me actually a long time to find these cartographic rules because we completely forget about them. But again, there is a direct relationship between the scale of work and the positional accuracy that you should obtain, right? So the maximum horizontal error you should get is function of the scale at which you are working. So, and this is linked. I mean, you can go back to the source here. It's basically, it's very interesting. It's linked to the size of the pen, the thickness of the pen that cartographers were using for drawing maps. And of course, the size, the thickness of the line will have a different equivalent in the reality depending on the scale of the map you're working with, right? So this is where the cartographic rule comes from. And what it says, if we go and take back again the scale to 1 to 100,000 that we were using earlier, you should not have an horizontal error above 52 meters in your when you take geographic coordinates. If you have more than 52 meters of horizontal error, so meaning your horizontal accuracy is lower than 52 meters, then you are collecting coordinates which are only usable at a different scale, right? So again, something that we forgot and which is very important to ensure consistency of the data, your resolution of your raster data should be of a certain value to be applicable for a certain set of scales, and at the same time, the accuracy of your geographic coordinates and therefore any of your geospatial data should also be within a given range to be able to be usable at a particular scale, right? And as you can see, you might remember from the previous slide, the values we have here are actually very similar to those we were looking at for the relationship between scale and resolution. But these are nevertheless two different and separated relationships, right? Because the positional accuracy and the resolution, again, are two different concepts, which means that when you are working with your raster format data, you should be looking at both. Your raster data should have a particular resolution to be used as a given scale, and at the same time should have a minimum positional accuracy to also be usable at that scale, right? So you need to be respecting those rules if you want to indeed at the end generate again good quality GIS-based products. Next. So to summarize, what's important here to remember is the purpose, right? What you have decided to use geospatial data and technologies for, which will be the entry point for you to have a good understanding of the geography of your program or your intervention, right? Which will lead to defining specific products that are needed to address a particular challenge, right? Or improve the performance of your program or your intervention. This purpose is going to drive the use of a specific scale, right? So the level of zooming, right? If you are basically, for example, if you are looking at micro-planning in an urban environment, you will need to zoom on those populated area more than if you want to do some monitoring at the district level for the whole country, right? So the scale of work will really depend on the purpose for which you are using geospatial data and technologies. And therefore, this level of zooming on the surface of the Earth. So the purpose defines the scale. The scale will directly influence the positional accuracy and the spatial resolution of the data that you should be compiling, collecting, extracting, or generating, and therefore using for generating those products, right? They need to be appropriate for the purpose you have defined, and therefore the scale you have decided to work on. Now, what's important to remember, right, is that the highest positional accuracy and precision possible is what you should be aiming at, right? Because this is what will allow you the largest number of use cases for the data you have collected, right? So you want to be aiming at high accuracy, high precision as much as possible, depending on the resources, right, that you have at disposal, of course, and the purpose that you have defined. But if you do this, you will have more possible use case that can be implemented with this data. And the last thing, of course, is remember to always get geographic coordinates or any data with 5 digits after the decimal point, right, to reach the precision level down to the method. Next. Okay, so this was for geospatial data. I know it's a bit heavy. There's maybe a lot of concept for some of you to absorb, but these are really critical things, which are, again, we are focusing here on content. We have not been talking about technology until now, right? We are module 4, and we have still not talked about technology, and that's on purpose, right? I mean, it's really critical for you to understand those concepts so that you are aware of and having this kind of almost surveillance system in your head and this light bulb turning on when you're going to be looking at data, or when you're going to be developing processes for collecting data to make sure that you will generate this data with the highest quality possible. So that was for geospatial data, right? And we went through these data specifications. Now, you also need to define this data specification for the other type of data we need to create GIS-based product. The first one being the georeference master list. What you have here is a fake example on how such specification would look like, as we have not yet applied this in the health sector. Actually, we have been applying this in the emergency management sector, but not in the health sector. But the template is already ready and operational. So what you can see here actually are specification for a georeference master list or any georeference master list for a given country. They are aligned to some extent, right? There is a part which is linked to geographic coordinate system. You have also accuracy in terms of positional accuracy and positional accuracy. So we define the same criteria here than for the geospatial data, because we want to ensure consistency, right? The other criteria are specific to master list and linked to terminology such as data dictionary and classification table that we will cover in a short while in the next session, right? But again, data specification for geospatial data, you should also have data specification for georeference master list. And then next one, you should also have data specification for statistical data, right? That you will be using as part of the geo-enablement in general and the development of GIS-based product in particular. Again, this is a fake example here for the health sector for the same reason as earlier. But what's important to know here is that ideally, these data specifications should be complemented by what we will call indicator reference sheet, right? Which is a description of each indicator that is being used. This is a completely different topic, right? This is going beyond the topic of the training workshop here. And I'm sure those who are basically statisticians on board, I mean, knows about these things. But what is key here is to remember that it's important to have a set of data specification also for this statistic data, so that the statistical data is going to be consistent with the georeference master list and consistent with the geospatial data that are being defined so that you obtain consistency more across all the different data sets you will be combining in order to create different GIS products. Okay, so this concludes the part of this session dedicated to the concept of data specification. Let me just have a quick look if there is any question in the Q&A. Is there any cutoff for accuracy and precision in geodata? So precision, again, 5 digits after the decimal point, so that you go down to the level, the meter level precision. When it comes to accuracy, it's for you to decide what will be appropriate for your application. But again, the higher the accuracy, the higher the number of use cases. And nowadays, with all the different satellite constellation we have in the sky, it's easy to go down below 10 meters of accuracy almost everywhere in the world. The value we are generally using is 15 meters, 1.5. So we are at a scale of 1 to 50,000 meters. That's generally what we are fixing. Okay, next slide. So now that we, yeah.
Steve, sorry.
Yes.
I think there's another question in the chat.
Ah, okay. I did not see this one.
Yes. From Rajesh. Is the CRS and geographic coordinate system same?
That's a good one. I think they are similar. I think this is the same. I will have to check. I'll do that during the break afterwards. I have a small doubt, unless maybe someone has an answer here and could be putting that in the chat. I think they are the same, but let me check during the break to be 100% sure, but I don't say something wrong right now. Thanks, Alexandre. I'll come back to this after the break. Okay. Going back now to the second part. So we look at data specifications. We're going to look now at ground reference. And the ground reference is really the closest reference you can have to the reality, which you will use to check data quality against, right? And in the context of what we do at the LGO lab, the ground reference is actually provided by two things. The first thing is high resolution orthorectified remote sensing imagery. I mean, accurate, high resolution orthorectified remote sensing imagery, I should say, which is something you will use for geospatial data. And then the second one are georeference master lists, which are used to assess and improve data quality, not only for geospatial data, but also statistical data. High resolution imagery, as you can see in the table here at the bottom, can be used to assess and improve completeness, timeliness, positional accuracy, and indirectly consistency. Master lists are themselves used to assess and improve data quality across the 6 dimensions of data quality. Next. So the imagery that can be used as ground reference can be collected through different ways, right? Using satellite, aircraft, or drone. What you are most likely going to use are medium and high resolution satellite imagery that you can actually access for free directly in your GIS software through what we call a web mapping service or using applications like Google Map or Bing Map. We'll come back to this in session 15. Next. So we have seen in module 1 already, we talked already a lot about georeference master lists, what they are. and also their importance for the geo-enablement in general, but also again the generation of GIS-based product of quality. Just to remind here that master lists are meant to contain the data elements that allow us to uniquely identify, classify, locate, and when applicable, contact each records features in the list. Any other data elements, according to us, is to be considered a programmatic attribute and managed basically outside of the master list. Next. So master lists are key to the HIS geo-enabling framework. And this is also one of the reasons why it's mentioned in several health program guidelines. It's also the subject of a growing number of master list specific documentation. And the one on the right here in the middle right, with the picture of the midwife, I'll come back to this one, which is the support guide for the development of National Reference Community Health Worker Master List, posted in our registry, is certainly the most comprehensive document on this topic. And this content is applicable actually to other geographic features, not only community health worker. And then also the concept of master list is at the origin of some global level initiative, like in relation to administrative units and health facilities. Next. There are several key elements to look into in relation to a master list when you want to establish, maintain, regularly update and share. Clear definition, right, behind the geographic feature for which the master list is being established. We covered this during session 6 of module 2 of the present training. There are all the elements in relation to the content. Focus on this in a moment. And then there is a need for a container, right, for this list. So a registry or a common registry, which is used to host, manage, regularly update, and share the content of the master list and associated information. And we'll come back to this in session 19 in module 5. It's an important concept and growing tool. And then there is a process through which the list is being established, maintained, regularly updated, and shared. So we'll focus on point 2 and 4 right now. Next. So first thing, when it comes to content, right, is the concept of data dictionary, which is basically a dictionary of all the data elements being captured in a database or an information system, or in this case, captured in the master list. This kind of dictionary is meant to capture the following information, the one you have on the right here for each data element, definition of the data element, applicability, format, size, values it can take, and also the indication if it is mandatory when adding a new record in the master list. So you need to develop such a dictionary for each master list, and you do that through ideally a consultative process, which will involve all the concerned stakeholders. And this is something that is well explained in the guidance I was mentioning earlier. Next. As I already mentioned also, the data elements which that are to be included in a master list are meant to cover these 4 groups of data elements, right? Uniquely identify, classify, locate, and contact. What you have here in the table are examples of these data elements for different geographic features. It's coming from the Geo-enabling microplanning handbook. It's just important to emphasize here that the inclusion of some data elements will depend on how the geographic feature is being defined, right? So taking the example of contact for vaccination post, of course, if a vaccination post is a temporary place, occupied by vaccination team at a certain point in time, then contact information are most probably not applicable. But if we are talking about a fixed infrastructure with permanent staff, then there should be some data elements to capture the contact information, right? There will be a person in charge, there will be a phone number, etc. Next. Another good example of a list of data elements across the 4 groups is the one provided for the community health worker master list. So in this case, 17 core data elements have been defined and considered as mandatory, right? To, again, uniquely identify, classify, locate, and contact community health workers. Next. And 16 additional data elements that have been defined and that can be added to the core ones depending on the context. Now, an important thing to remember when you decide on these data elements is that the more you include, the more difficult it is to maintain the quality of this information in the long term, right? So you want to find the right balance between exhaustiveness and sustainability when you define such content. Next. One thing that is important to clarify, because you might have heard different terms when it comes to health facilities, right? You might have heard the concept of health facility master list, HFML, and you might have also heard the concept of master facility list. Both are used in different documents. The last one in the master facility resource package you have here on the upper right. For that, I mean, we need to go back to the source, and back in 2007, there's one document that was released, which was called a signature domain. And this document is at the origin of the 4 groups of data elements to be included in the master list, right? And therefore, a health facility master list. Again, uniquely identify, classify, locate, and contact. The concept of master facility list was itself released 11 years after that in 2018 and include another domain, the signature domain, and a set of data elements in relation to that. That covers services being offered, human resources, and also infrastructure, right? So signature domain was at the beginning focusing on the object itself. The service domain was added after that. Of course, it's tempting to kind of be willing to combine the two into the same database, which is the reason why the master facility concept include the service domain into its definition, while the health facility master list doesn't. Now, next. What is important, and this is something, again, going back to what I was mentioning earlier, the importance of the process to define the data dictionary, and therefore the data elements you would include in your master list. You should carefully consider what you include, because when you cover the 4 groups of data element part of the signature domain, you can already reach quite a significant number of data elements. We have an example here on the right for Mongolia, where a preliminary exercise for the master list of health facilities identified 33 data elements purely for the signature domain, right? So that's already a lot of elements to manage. Now, the current mandate over service domain data elements compared to signature domain can be spread among several entities and have different life cycle, right? For example, the proper updating mechanism, which makes it more complicated to be merged and integrated into one single list. And the last one is that service domain data elements can be considered more sensitive than the signature domain ones, right? because it will include information about the personnel, about certain potential vulnerabilities of the infrastructure, and might therefore require additional protection measures, data protection measures, right, and specific for distribution rights, which is why what we have been promoting until now is for the different information system containing the service domain data to be synchronized with the health facility master list, right? So keeping the health facility master list, focusing on the 4 groups, and then synchronizing with the different information system that will include this service domain information and use the unique identifier of the health facility to link all of this together. I mean, this is just to emphasize the importance really of looking into this and also the impact of these different master lists in the development even of your information system, right? And all the data model, the data architecture behind your information system. Next. So this is just on defining, right, the data elements, the importance to look into this exercise. Certain data elements are meant to be presenting values that are part of a limited set of options, right? This is, for example, the case for health facility types or health facility ownership. When this is the case, what we call a classification table should be generated to organize and categorize the values that such data elements can take, right? So doing so, developing this classification table ensure consistency across all the records in the master list, right? You have here an example of a classification table for facility types in Cambodia, where then this information is like standardized and the value which are in this classification table will be applied to all the records in the master list. Next. Now, after that dictionary, data elements, classification table, the next critical thing, which is very, which importance is very often underlooked and might result in huge problem in the long term, is the definition of an inappropriate coding system to uniquely identify each record in a master list. There are some core rules that should always be applied to avoid these problems. If you don't apply these rules, you might find yourself having to take some difficult decision at some point, which might have a big impact on your information system, especially if these coding systems have been used by many different programs over a long period of time. The first important rule is not to include any information that can change through time in your coding system if it applies to an infrastructure like an health facility, for example. I know it's tempting to get information through the unique ID, but as soon as it changes, you will find yourself in front of a difficult decision to take. We'll come back to this. Second rule, avoid, of course, long coding system as much as possible. Identify really, how many of these features do you have today? Or could they evolve through time in the coming decades or even century? And do not get to have a sequence longer than what is necessary. It can be very painful, especially depending on the type of applications you're using. And third rule, don't use a schema that uses 0 at the beginning of the sequence. I've seen and continue to see that every single year in different countries. The problem is, for those, some of you might have experienced that, the 0 falls in different applications. It makes the unique, ID being recognized in different formats by different applications, and this might generate a big problem. So first 3 golden rule in relation to coding system. Next. The next important rule is to ensure that the unique ID associated to a geographic feature remains the same from the start until the end of its existence. And this independently to what happens to that object, basically. If we take a health facility, for example, change in name, change in type, or even location should not result in a change of its unique ID. If you want to be able to basically track through time all the associated statistical data, for example. All the other information that change, right, in relation of the type, the change of type, right, the change of name, the change even of location is something that is supposed to be managed by the IT solution serving as a health facility registry. Right? This is what allows really for changes to be not only captured, but to be also retrieved for different periods in time. Next. Now, if you really like to be able to quickly identify which administrative unit a health facility is located, you can always use what we can call a geotag, right? So this is a tag which is generated on the fly by merging different information, which provides you a sequence of information like the unique ID of the administrative unit in which the facility is located with its unique ID, right? Like you have an example here of geotag. So if really your boss, or it's useful for you to have that quickly. You generate that on the fly. Now, what's important to remember is this is not a unique identifier. That cannot be used as a unique identifier because it will change through time. So this is just on-the-go information that can be useful for you to use. Next. Along the same line of the unique identifier, it's also very important to look into following specific naming conventions, right? And this is to reach a situation where the name of each of your geographic feature is unique. That's particularly useful in applications where you do data entry based on the name of the health facility, for example. There are some countries, and you have some examples here for Myanmar, where you have several health facilities with exactly the same name in different parts of the country. So you may want to put some rules in place to ensure that you avoid this, like here, what we have been doing in Myanmar was to either include the name of the health facility to which they are referring to, or the name of the township in which they are currently located to be able to make the distinction between the two. But again, also along the line of uniquely identifying facilities, you want to be doing that. Next. Location, right? After uniquely identifying location is an important core data elements. You can capture location in different ways. Good to capture all the different ways when it's possible. That can first be through an address when applicable, right? Especially in urban areas. Then, of course, there's the location of the infrastructure within the administrative structure, which is not only useful as a location indication, but also to check the accuracy of geographic coordinates associated to its geographic features. And there it's important to remember that administrative division change through time as well, right? So you need to have also access to a master list of administrative units and settlements, and that need to come from the governmental entity having the curation mandate over that list. Next. And then, of course, accurate and precise geographic coordinates. Right, for the geographic features that you represent by a point in the GIS. Now, it's also critical to capture the source, the method, as well as the qualitative measure of accuracy, right, attached to these coordinates, as per the example you have here on the side, because this information is important to judge the quality of these coordinates. This brings us back to the specification we talked about earlier, the need to capture 5 digits after the decimal points, right, and to obtain a precision level down to the method. All of this is critical, as these coordinates are, of course, the entry point to all the potential application of geospatial technologies, I mean, especially GIS in public health. Next. Last group of data elements, which apply mostly to infrastructures, is related to contact information, right? We're talking about information that will allow to contact the infrastructure. Once again, you can certainly imagine the number of data elements needed to cover this, as well as the 4 groups. So all of this ideally is to be covered. Next. Just one slide to highlight the process, which is very well documented and detailed in the implementation support guide for the development of a national georeference community health worker master list. No rocket science, as you can see, and steps that can be applied to any master list. I invite you to go through the guide for further details. So this concludes this session for today. The first session for today, not the module. Stay with me, we still have some way to go. Very long, I know, sorry, but very important. I don't see any question in the Q&A. I see that there is an answer potentially for the difference between CRS and geographic coordinate. I will have a look at that. But let's have a 10-minute break. Let's start again in, so it's at 15 to the hour. It's 3 o'clock my time, 3 o'clock, 3 or 4. Let's restart at 3:15 for the next sessions. Talk to you in 10 minutes. Thank you. Please come back. We're not finished for today. For those who can stay, I know it's a long session. But some interesting things coming in 10 minutes of the recording. Thank you and welcome back for this second part. Thanks for those who have the possibility to stay longer today. As mentioned, this session is this module today is longer than the other ones due to the importance of the topic. Next, we'll now basically look into an important topic. I mean, it's going to be a short session, but it's a very, very important topic, nevertheless, which is about documenting the data. And I wanted to emphasize that again, because this is very often overlooked. Next. As mentioning earlier, documentation is a key activity, right, of the geospatial data management cycle. We talked about the importance of documenting the whole process earlier. Now I want to talk about the documentation of the data itself. And this applies again to any type of data, georeference master list, geospatial data, as well as statistical data. This is the topic of one guidance document from the Health Geo Lab, the volume 251, which you find also in the Google Drive. Sorry. Next. So we went already through the definition of what metadata is a few times already. I will not spend too much time here, just emphasize once again that it applies to any type of data, and we should start collecting the information to enter in these metadata as soon as you finish preparing the data specifications. Next. What I would like to focus on now is really the content of what constitutes a good metadata for any type of data. So such content should allow to answer the questions you have listed here, question which are basically linked to the what, the who, the when, and how of the data itself, right? What is the data about? Who created it? When was it created? How was it created? On which data specifications was this data created? Is there any use or distribution restriction? And who can I contact in case I have additional questions about it? Next. So all of this is meant to be captured what we call a metadata record, which is itself based on a metadata profile. So this profile is the result of the contextualization of a metadata standard. The most widely used metadata standards are those produced by ISO and to some extent the Federal Geographic Data Committee. But I just recently found these past days that the FGDC is actually encouraging federal agencies in the US to also transition to the ISO metadata standards. So it makes sense between the two to look into using the ISO one. Next. So what we have done for geospatial data at the GeoLab is to create a specific metadata profile out of the ISO metadata standards. And we have documented that profile in guidance 251. This profile contains 30 fields that are ideally to be filled to cover the questions mentioned earlier. Next. When it comes to georeference master list, there are no specific standards existing. What we have therefore been promoting is the use of a simple data catalog and also a metadata profile to be attached with the master list. These are also documented in the guidance. So it's basically giving a list and a description of the fields which are included in the master list. So that's what is in the data catalog. And it's then giving the basic information about the what, the when, the who, and the how in the metadata profile. Next. Something similar also that we recommend to be applied for statistical data because the existing standards are either not straightforward or more for, not straightforward for an IT professional. So we have developed also, promote the same approach of a simple data catalog and also a short metadata profile to capture the metadata for statistical data. Next. One last slide to explain why we prefer to use an Excel file when sharing a master list of statistical data, which is the possibility to store the data catalog and the metadata in the same file as the master list or the statistical data. So that way the three of them stay together, they are not lost when they are being shared. So this is all about metadata. But I really wanted to have a specific session dedicated to this, encouraging you to not only document your data using a metadata profile, but also each time you're asking for data that you are planning to use for your project, to get the metadata from these basically data to make sure that it corresponds to what you need. Thanks. Next slide. Last session for today, we'll look at the next step, right, in the data management cycle. Now, when it comes to assessing data availability, accessibility, and quality. So now we have defined all the benchmark, right? We have the specifications. We have defined also the ground reference, and we can now compile existing available data and also identify potential gaps. Next. So these are the steps in the overall cycle. These steps are documented also in two guidance of the LGO lab, two sets of guidance. Guidance 2.3 when it comes to compiling and identifying gaps. And there is also two guidance in relation to filling the gaps. We'll come back to that in a short while. Next. So what is the data that you need to compile? Well, basically, it's all the data that you have identified during the steps which allow to define the data needs, right? So at the beginning of the cycle, right? Depending on the application of geospatial data and technologies that you are considering, and therefore the GIS products to be generated, this may include data and information to establish one or more master list, or compiling the master list themselves if they exist. It can also be geospatial data, statistical data, but also input parameters that you might need to be able to conduct certain analysis. Like, for example, travel scenarios for accessibility analysis. For all this data and information, again, it's important to obtain, to keep the metadata, as it will be used during the quality assessment part of the process. Next. When it comes to the ideal source of the data to be compiled, of course, by definition, master lists should only come from the governmental entities that have the official curation mandate over each considered geographic feature. The table that you have on these slides provide the list of such anticipated governmental entities for different types of geographic features, those mostly used in public health. And as it's very similar to the table earlier, we can notice that the master list is not required for certain geographic features, of course, like transportation network, land cover, etc. Next. So while the master list should always come from the governmental entity having the curation mandate, this is not always possible, right, for the geospatial data itself, for reason of availability, accessibility, or sometimes quality reasons, right? So when this is the case, non-governmental source can be also considered. Such source can be NGOs, voluntary groups. One very well-known source for the latter, right, is of course the OpenStreetMap dataset, for example. It can also be data coming out of research groups or universities, like it's the case with the World Population Distribution dataset. But again, like any other data, the quality and also possible restrictions toward the use of this data will also need to be identified before deciding if it can be used. Next. You have here some examples of these other global data sets, freely accessible data sources. I already mentioned OpenStreetMap for transportation and geographic network, and WorldPop also for population distribution. What you have here is some data set also for altitude, digital elevation model, land cover, and building footprint, which are very useful data set when you don't have what you need at the national level. Next. One slide just to emphasize the importance to properly organize the data that you compile. and also not the one you compile, but also subsequently generate, and this to facilitate for it to be found and therefore being used and reused, not only by yourself, but also by others, if you're sharing it among the member of a group or an organization, for example. What you have here is an example of organizational structure using 3 levels. But you can come up with other ones, of course, depending on what works best for you, and ensure that everybody is going to be able to find easily and rapidly the data they are looking for. Next. Once you have compiled and organized the available and accessible data, there will most likely be a need to clean and homogenize it, right, in terms of validity, format, structure, and also uniqueness, remove duplicates. In the case of list, you would have compiled. The work to be done might include deleting data elements identified as being of poor quality, unmerging multiple informations stored in the same column, adjusting values to fit the format, defining the data specification, etc., etc. Once this is done, and if there are multiple lists, this can then be merged to generate the first draft of master list for which gaps can then be identified. When it comes to geospatial data, example on the right, there might be a need to align the data you have compiled to the defined data specifications in terms of geographic coordinate system, for example, to make sure that you will be compatible, right? And when applicable, also align the content of the attribute table with the corresponding master list. So at the end of this exercise, you will then have geospatial data for which gaps can be identified. But again, you cannot jump directly into identifying gap. There is some work that needs to be done first to prepare the data for this exercise. Next. It's important to emphasize that a significant part of the cleaning and homogenization work performed on the list that you will have compiled will take place in Excel, right? Not in the GIS. So it's only at a later stage that you will upload and manage that in a GIS or in a registry or a common georegistry. So it's important to know how to use a set of functions and tools that are available in Excel. And this is the reason for another guidance document that we have created at the Help Geo Lab, the 2.5.2, which is freely accessible and which does not only cover these functionalities and tools, but also provide sample data and SOPs to test them. Next. Another critical things to be aware when you are cleaning and homogenizing the compiled data is the temporal representativity of geospatial data, right? A GIS software will never automatically warn you when you are overlaying on top of each other data sets that have been generated or collected at different points in time, right? You need to be conscious about this and check the metadata to avoid what we call temporal discrepancies, which might have a significant impact on your application or the use of GIS-based products, right? You just have an illustration here. If you were to basically overlay, combine, analyze roads from 2023 with land cover, which is 23 years old, population, which is also 14 years old, etc. You, of course, might have huge differences. Things might have changed a lot in between, and you might therefore end up a result that will not be representative of the situation observed today in the country. So we need to be very careful about that. Next. Once the available and accessible data has been compiled, organized, and cleaned, and homogenized, and checked for potential discrepancies, temporal discrepancies, then you can look at identifying potential data gaps. So these gaps can be of two main types. I mean, the first one, you basically have no data available. There's no source available for the data. In this case, of course, that gaps is much more important and difficult potentially to be filled compared to the second case where you might have some gaps across some or all of the 6 dimensions of data quality. So you have some data set, but there are some gaps across some of the dimension. So for example, on the left, in the case of a master list, you might have values or informations that are missing for certain data elements. So it's a completeness issue. There might be some uncertainties about values of information, for example, the accuracy of the geographic coordinates, that's a validity concern, or the information might simply be outdated. That's a timeliness and data quality issues. And when it comes to geospatial data, some geographic features might be missing, again, completeness. Feature might not be aligned with the geographic, the ground reference, so that's an accuracy problem. And there might be inconsistencies also between data sets, that they are not aligning together. So these are examples of gap. Next. A set of resources to help you identify these gaps, first in relation to lists and master lists. So in the same guidance, right, for community health worker master list, you will find a set of questions to support the assessment of the quality of your list, and this across the 6 dimensions of data quality. And this is applicable not only to community health worker, but any other master list. Once you have applied and answered the questions that are in there, you might be faced with different scenarios, right? Either none of the lists actually contain the information that is to be considered of sufficient quality. You might then have to create the master list from scratch. Only one list contains information considered to be of quality, then you will continue working only on that list. Or you might have several lists containing pieces of information that are of quality and which will need to be merged. So again, this process is explained very well in this guidance. Next. The volume 2.3 of the Health Geo Lab guidance does itself provide you with a list of questions to ask to identify potential gaps in geospatial data, again, across the 6 dimensions. So this is something you can use, again, as a tool to be able to identify this gap at this particular stage. Next. And the same guidance also contains the list of questions to ask in relation to the statistical data you might be using as part of the use of geospatial data and technologies, right, for generating some specific products. More limited number of questions, but again, trying to make sure that the statistical data is aligned with the master list and the geospatial data for its use in the application. Next. Now, all the gaps that you have identified during this exercise should be documented. And this documentation used as the reference for developing the data component of the action plan, right? Before that, before even reaching the development of the plan, I mean, once the gap is known, you might want to first, again, double check if you did not miss any data source, right? During the data compilation exercise, doing that twice, especially if you have big gaps, like for a particular data set, you have no source at all, worth to do a second round. Now, if that's not the case, if there's really nothing, then of course the gaps will need to be filled. Next. Now, you might not fill the gaps just right after the assessment, right? You might, as I mentioned earlier, do that as part of the implementation of the action plan. This being said, it's important at this stage to estimate if and how the gaps that have been identified can be filled, right? Because this information will be needed to develop the action plan. So of course, there are different methods that can be used to fill these gaps. We'll come back to this in a minute. What's important to remember is to start by filling the gaps in the master list, because the master lists are serving as the ground reference for geospatial and statistical data. So you will need it. You will need this master list as your reference, as your denominator for capturing other data sets. And the other thing is, of course, also not to forget about data validation as part of your process, right? To ensure really the highest quality possible of the resulting data. And once again, all of this applies to any type of data that we have been considering until now. Georeference, master list, geospatial data, and statistical data, right? Next. So when it comes to methods, the Geo-enabling micro-planning handbook provides the following table, which indicate which ones can be used, which method can be used, depending on the type of vector format, geospatial data, and a few other type of data, right? So you have here different methods to fill gaps for point line polygons. This is vector format data. And you also have some indication on the method to be used for other type of data. Two of the Help GeoLab guidance document covers several of these methods. Right, the ones circled in blue and in green. So these are, again, two documents that you can refer to in relation to that. Next. When it comes to filling gaps in the master list, the first important thing to do before collecting missing or unreliable data is to validate the list itself to make sure that, first of all, it's complete in terms of all currently existing operational records, right? So you want to make sure your list has all the currently operational facilities before you do any data collection on it. You want to make sure also that the list contains the indication of the administrative unit information down to the lowest level possible, as this information will be useful to check the quality of geographic coordinates that are included in your, if they are included in your master list. And you want to make sure also your master list doesn't include any duplicates that might have been missed during the cleaning and homogenization steps, right? So in relation to that, it's really important to identify at which level the validation should take place, right? To make sure that you involve the right person having the knowledge as close as possible to the ground for the validation. Now, depending on the context and of the different geographical, the considered geographic features, it's also possible to look into integrating the validation step into the first phase of the field data collection exercise. That's something that has been done in certain countries. So you start your data collection exercise in a district, for example, by having a consultation with the district officer to make sure that your master list is complete, and then you start your data collection exercise. So there are different ways to look into that, but important to make sure you do that to not miss any facilities, for example. Next. So once completeness in terms of the records has been confirmed, right, by the appropriate authority, it is then possible to collect missing, uncertain, or dated data. Now, it's good to distinguish between two types of data at this stage, as the method used for data collection might be different, right? You have on one side, you have the collection of geographic coordinates, On the other side, you might have collection of any other data elements included in the list. In both cases, it's crucial that you define documents and ensure the use of the same standard operating procedure by all the data collectors after they have been trained on how to use it, right? This is the only way to ensure not only the effectiveness of the exercise, but also the quality of the data that has been collected. A key point to emphasize here as well is the need for the unique identifier, right, that is attributed to each geographic features in the master list to be included in the data collection instrument, the form, right, to be able at the end to link any data collected in the field with the correct record in the master list after the data collection. Next. So when it comes to collecting geographic coordinates, we have defined and documented 12 different methods organized in the table here, and these according to the main data use, so the purpose and also the level of scalability of each method. This table together with the SOP, so there is an SOP documented for each of these methods, captured in volume 242 of the Help GeoLab guidance documents. Next. When you use this table on the previous slide to select a method, it's important to remember that if you have pre-existing digital electronic field data collection system, you should be, and these system allows to, provide the necessary functionalities and to reach the needed level of accuracy and precision, then you should be, of course, using those systems as much as possible to collect any new data. If you are using an electronic form, right, that's also something that will reduce data collection time and data entry errors, right? So it's preferable over paper form if it's possible. That's applied for any type of data collection exercise, right? And as mentioned earlier already, the higher the accuracy and the precision of the coordinates that you're collecting, the greater the number of use cases that you can complete with it, right? And last but not least, the method, there are some of the methods, right, in this table among the 12 methods that are only based on an offline map, right? So you can download the map on your device, and the user will use that map to kind of identify the coordinates. That is possible, of course, but that will require also for the data collectors to know how to navigate on the map or imagery and to recognize the term, right, the places, the areas from an aerial view, which is not necessarily an easy skill if you have never done that before. And I just realized, we have a question in the chat, in the Q&A, which is related to data collection, which is quite interesting. And maybe that's not a bad time to look at it. The question from Ganso, can geospatial data be assigned after conducting the micro plan of a program? That is, if you miss the opportunity to design and collect data simultaneously during a micro-planning exercise. Well, of course, it's a lost opportunity not to have the geospatial data prior to developing the micro-plan, right? Because that geospatial data could have helped you develop the plan. So this is the first thing. Now, if you have not been able to do that before developing the micro-plan, you might actually want, because your micro plan will be updated every year, right? So you might want to potentially wait for the next cycle to basically plan for this exercise to take place at the right moment, and therefore take advantage of this data collection exercise if it can be happening before the development of the plan so that it influences the plan, right? if you, and I guess that's what you're describing here, right? So that it will be doing it. So I will do this. I will wait for the next round to do the data collection at that moment. Now, if you want to take advantage for maybe not doing this data collection for the entire country, but just for a pilot, right? And you want to just do it anyway in anticipation of the next round, that's also not a bad thing to do, right? So you could be doing, implementing the approach outside of the regular micro-planning process as a way of testing the different methods on a smaller area. And then once this is tested, documented, and also integrated in the micro-planning process, then roll that out during the next round of the micro-planning phase. Okay, coming back to the slides here, and the next one, actually. So independent from the method that you will be using for collecting geographic coordinates, you will always need a data collection form, right? You will always need a standard operating procedure, and you will always need also some master list, at least for the geographic features for which you need to collect the geographic coordinates, right? And so this goes also in favor to the answer I just gave to the question that was in the Q&A. You may want to also take the opportunity to make sure that you have well thought the data collection form, the SOP, and also you have the master list and have tested all of this, right? So a proper data collection form should include all the fields allowing to capture what you have listed here. And you have some examples again in this guidance of these kind of forms. Next. The SOP itself, so the standard operating procedure, should really contain the details of all the steps to be followed by the data collectors when they are in the field to collect and verify the quality of the geographic coordinates. This SOP should be ready, tested, and used during the training of the data collectors, right? And it should really focus on the essential information needed by the data collectors, be as clear as possible, and also cover, of course, all the fields in the forms. And illustrations are always useful to help data collector complete each step. Next. When it comes to the master list, you actually need two of them generally to support the collection of geographic coordinates, right? The master list of the features for which you need to capture the coordinates, right? Like the facilities, and also the master list of administrative units for the areas to be covered by the data collection exercise, because you will enter this information also in the data collection form. There's also some additional equipment or items that might be needed depending on the method being used, right? You have them listed here. And again, this is documented for each SOP in the guidance document. Next. Now, several things to be cautious about and to be implemented before, during, and after data collections for geographic coordinates. Before data collection, right, the preparation of all the material needed to implement the method, the selection of the people that will be responsible for data collection, and also supervision, and the training, right? I mean, the training is really the key to ensure proper data collection exercise, and you want to be including as many practical exercise as needed during that particular training, right? And repeat it several times until really people, the data collector, are clear about each of the steps and the coordinates they collect are of quality. Next. During data collection, the most important is to ensure that the data collector, again, are following the SOP for which they have been trained, really step by step. And that's why it's also important to have a mechanism in place to rapidly detect and resolve unexpected issue, like you will do for any other kind of surveys. And you will want to do that while data collectors are still in the field, right? To be able to recollect coordinates if needed. What can be done in this regards depends on the availability of resources, right? And the geographic extent of the area that you are covering. What you can do is organize on-site spot checks of data accuracy and completeness conducted by the supervisor. You can also put system in place remotely. We've been using that a lot, and it works efficiently, where you can ask data collectors to include what they have collected during the day in a Google spreadsheet, for example, and get that being checked remotely. Next. Once the data collection exercise is completed, of course, important to organize the data in a structured way, make sure it's complete, right? So there's some cleaning, some checking, some homogenizing to take place, like any data collection exercise. And good habit, include a data catalog, right? To be able for the users to identify what is included in each of the fields. In the spreadsheet containing the result, and also a metadata spreadsheet with it. Next. Okay, so we just covered the collection of geographic coordinates in the fields. This is obviously not a method that you will use for other type of geospatial data, right? This is specific for point type data. If you were to, you need some line or polygons, raster format data, you will be using other type of method, right? And you have them listed here depending on the format. The one that is circled in red is most likely the one you will be using, right? So the adjustment, creation of points out of base map. So this is the one we'll be looking at a little bit more in detail now. Next. So adjusting vector format geospatial data using a base map, generally imagery, right, consists in using such base map as a ground reference to first identify geographic features that are too far from the, the real feature on the image, right? You have here an example of a road in yellow in the data set, which is 300 meters away from the real road in the satellite imagery. And if this is above the positional accuracy captured in the data specifications, you may want to then adjust this. So you will do some editing work to be able to move, as you have just in the lower left image, move this segment of road to the right position, right? So a GIS software is used to do that. You can do that on the directly on your screen. The example on the right is a case where a segment of road is completely missing from the image, and you can therefore add data to this data set using, again, the satellite image as a reference, as a ground reference. All of that is explained in the guidance document, again, the same guidance as earlier. Next. Now, it's important, of course, when you're doing that, to do this kind of editing of extraction of vector data from a base map. It's important to choose the appropriate base map, right? So the base map has to respect the data specifications in terms of accuracy, in terms of resolution. You want to make sure if you use imagery, it's free of clouds as much as possible. And you want to make sure also that the image are well orthorectified, so means readjusted to avoid duplicates and therefore errors when you do the editing. Next. You then have to also select the appropriate method you will use to do the work, right? And there are, again, different methods: manual extraction, so purely fully manually human guided, interactive extraction, which is a mix between automated and manual basically work. Or you can have also, you have fully automated methods that will automatically extract the pattern from satellite imagery, can recognize roads or buildings, for example. Next. Now, quickly, just an example, because we have been talking now about, until now, about collecting geographic coordinates and filling gaps in geospatial data. But it's also good to know that geospatial data and technologies can be used to fill gaps in population estimates, right, and spatial distribution. This is something which has shown, of course, a growing interest. Knowing where the population is located is critical for the implementation of any program or intervention. And so there are different type of gaps that can be used, that can be filled using geospatial data and technologies. You have the three main gaps here. You can have gaps, you need to expand the geographic extent of the available data. You have some hole in your population distribution for different reasons, and that can be used. So it's a bottom-up approach to fill the gaps. The second one aim at increasing the resolution. So let's say you have population data only at the district level, and you want population data at the sub-district level. So there are methods existing also to do that. And there are also methods which allows to project in time, right? So you want to have more recent estimates of population, and that can also be done. All of these methods are described in the Geo-enabling microplanning handbook. So I invite you to have a look at that for more information. Next. Now, at the end, it's important to remember that it might not be possible to fill some gaps, right? And this by lack of time or resources. When this happens, you're going to have to take a decision on what you decide to do with this. And so either you said, okay, the quality of the data is still sufficient for doing the rest of the work, and then you will decide to go forward and produce these GIS-based products. Just have to be careful about the impact this might have on decision making, right? That's the first option. The second one is you decide that the quality is insufficient, and that's a major limitation. So you might have to postpone the creation of GIS-based product until you have the necessary time and resources. Or the last option is that you think the quality is sufficient, but is insufficient, sorry, but the gap could be addressed as part of the action plan. So you may want to include that in the updating, either in the action plan or the operationalization of the updating mechanism. Next. And I just arrived on time. I said 3 hours, we'll get there. Last thing for today was to give you the schedule and agenda for the 5th module taking place on August 28th. We'll talk about technology this time. After focusing on the process and the content, so look into technology. Next one. And thank you so much. I know it was long. I know it was a lot of new things today. That's why we have the recording. And so please don't hesitate to basically look at the slides that will be shared with you as well. Look at the recording. I will answer. There's one more question there, and I will answer that separately. And thanks again for your attention. See you all again soon. Bye-bye.